All right, so you just watched the introduction to 15.2 of U-Substitution. So let's continue the idea, looking at the process one more time of U-Substitution and identifying different steps you can follow. So when I see a chain rule kind of problem, an antiderivative but looks like a chain rule problem, we're going to try to do U-Substitution. So step number one is we're going to try to identify the U. And it's usually what we call the inside part of that function. And then we're going to take his derivative. We're going to find the derivative of u with respect to x. We're going to multiply both sides by dx so we can get a du. We're then going to take our original problem. We're going to take out what we called u and substitute u in. We're going to find our du and substitute that in. And the entire integral should be written in terms of u and du then. There should be no more x's left, right? That's what our purpose was of substituting, is getting rid of the x's and substituting in all u's. We're then going to integrate in terms of u, and then our last step is to back substitute in what we called u in the first place. Okay, so a couple different steps we're going to follow anytime we see a U-substitution problem. So here's our example number one. It asks us to integrate, find the indefinite integral with respect to x. And the old way, we would have had to FOIL this out 7 times. I don't want to do that. So let's see if we can use our U-substitution. So what do you think that we're going to call u in this particular problem? Remember, typically u is the inside stuff. So I'm going to start by calling u the 3x squared plus 4. I'm going to try it, kind of like a puzzle. I'm going to try this piece, and if it doesn't work, then I can always try a new piece. But I'm going to start with calling u the 3x squared plus 4. I'm now going to find the derivative. So what's the derivative of 3x squared plus 4? You should get 6x. And then multiply both sides by dx, so I get a du of 6x dx. So now let's go back to the original problem and let's do our substitution. So instead of calling this 3x squared plus 4, can't we take that out and really call it u, or now u to the 7th? And then we have left a 6x dx, which is perfect because 6x dx is equivalent to my du. So now I have a new problem that asks me to integrate u to the 7th with respect to u. So I can use my power rule now that we learned from a previous section. I can add 1 to the exponent and divide by that new exponent. Remember to add your constant of integration as soon as you integrate. But we don't want our answers in terms of u. We want our answers in terms of x's because that's how they asked it in the first place. So our last step is to just back substitute what we called u, which was my 3x squared plus 4. So the antiderivative of my original problem is this quantity here, 3x squared plus 4 to the 8th power over 8 plus c. Way easier than FOILing out 7 times. Let's do another one. All right, if this were a derivative problem, to me this looks like a chain rule problem, right? Where this would be my x cubed plus 1, remember, to the 1/2 power. And so it looks like a chain rule. So instead of doing chain rule, since we don't have a chain rule for antiderivatives, let's see if we can use U-substitution. So in this problem, what do you think we're going to call u? Yeah, I called u that inside stuff, the x cubed plus 1. I'm now going to find the derivative. The derivative of x squared plus 1 is 3x squared. I'm going to multiply both sides by dx, so I end up with a du of 3x squared dx. So now let's take our original function and let's substitute in what we called u and du. This is what I have. I had this. We use a 1/2 instead of a radical. And so now I'm going to take this x cubed plus 1, and instead of calling him x cubed plus 1, could I really call him u? So now he's a u to the 1/2. That takes care of all that piece, right? But then I need to make sure that I can have my du back here. But remember, du was 3x squared dx. Ooh, and it looks like I'm missing a 3, aren't I? And in order for me to be able to take all this stuff out and call it du, I need that extra 3 in there. And in math, you can't just force a 3 in there because then you've just tripled your problem. It's not the same value as it originally was. So we need to somehow think of how we can put a 3 in there without actually affecting the value of my problem. So if I put in a 3, if I multiplied something by 3, could I actually go back and divide it by 3 or multiply it by 1/3? Because technically then wouldn't the 3's cancel each other out and then I wouldn't really be affecting the value of my problem? But now I have a 3 in here, and now I have a 3x squared dx. I have everything I need to be able to call that du. So I can take this 3x squared dx, I can call it du, but I still have the 1/3 that's out in front. I needed that 1/3 so that I can put in a 3, and I'm allowed to do that as long as it's just a number and I balance them out. So I put in a 3, as long as I multiplied it by 3, as long as I went back and divided it by 3 or multiplied it by 1/3. I then used the 3x squared dx and called it du, so all of that went away, and I still have a 1/3 in the front. So now I have a new problem that says 1/3 times the indefinite integral of u to the 1/2 du. It's a much more simplified problem. I have all the pieces that I need, especially because I balanced out my 3 that I put in there with the 1/3. And now I can use my power rule to find the antiderivative. I'm going to add 1 to the exponent, so adding 1 would give me, what, a 3/2? I'm going to divide by 3/2, but actually instead of dividing by 3/2 and having a triple layer fraction, I'm going to multiply by his reciprocal, so 2/3. I'm going to add my constant of integration so I don't forget, and then I still have a 1/3 out in front that I can't forget as well. So, kind of combining it a little bit, I have a 2u to the 3/2 over 9 plus c. Remember, my last step is to back substitute. Don't leave your answer in terms of u's. Let's back substitute in for what we called x's, or what we called u's, as x cubed plus 1. So my antiderivative would be this. If you don't believe me, double check it. Try finding the derivative and see if you come back with the original problem. You should, and so that's an easy way to double check. If you have time on your test, why not? Find the antiderivative and then find the derivative and see if you got the same answer. Okay? Practice those few first before you do